Welcome to the MecSoft User Spotlight series, where you can find real customers achieving their success with MecSoft products. Today we'll be spotlighting Dingwall guitars and their use of VisualCAD CNC software. Sheldon Dingwall in Dingwall Guitars from Saskatoon, SK, Canada, is one of the pioneers in the development of today's multi-scale fan-fret electric bass guitars. Sheldon was a player from a very young age, first learning the piano at age 5, drums and then guitar at age 12, but Sheldon didn't stop there. He decided to build his own guitar in his uncle's cabinet shop, where he learned the critical woodworking skills from a master craftsman. Dingwall Guitars has been operating continuously for the past 32 years, manufacturing thousands of their electric bass guitars from their 8,000 square foot facility. Sheldon learned early on the importance of digital manufacturing. He has successfully implemented VisualCAD from MecSoft Corporation with their Fadal CNC milling center on thousands of components over the past 20 years. We recently sat down with Sheldon to learn more about the Dingwall brand and how VisualCAD fits into their manufacturing process. Here is some of what Sheldon had to say about VisualCAD. The VisualCAD project chosen for this case study is the CNC machined body of the Dingwall D-ROC electric bass guitar in its standard configuration. The D-ROC is one of 3 ready-to-play guitar models from the Dingwall line. See more electric bass guitars in the Dingwall line further on in this video. What sets this VisualCAD part file apart from other 3-axis machining jobs is that it only has one 3D surface required. Both the top and back are 3D contoured. It is used to define the sculpted top face of the D-ROC body. The remaining geometry are 2D and 3D curves. These curves are used to drive each of the 2.5-axis and 3-axis toolpaths used to complete the machining job. The VisualCAD part file shown here, the 3D contour surface is colored in deep violet. The remaining geometry curves are black, and the stock definition is shown transparent. The machining job tree and tool library are shown on the left of the display. The quad viewport shows the top, front, side, and isometric view of the D-ROC body geometry. The VisualCAM machining job for the Dingwall D-ROC body consists of one 3-axis setup, output to the Fadal 88HS post-processor. The stock is defined as an extrusion of the outer perimeter curve, defined as region stock in the machining job tree. The actual stock material for this project is kaya, known as African mahogany. The setup consists of 5 machining operation sets, referred to as mop sets. Each mop set contains multiple machining operations, grouped by tool definition and other factors. The first mop set contains 3-axis rough and finishing operations for the upper contoured face of the Dingwall D-ROC body. The remaining mop sets contain operations for the 2.5-axis roughing, pre-finishing, and finishing toolpaths used to complete the machining job. The machining job tree, stock, and completed cut material simulations are shown here. In the top left, we see the stock model. In the lower left, we see the completed machining job. On the right, we see the VisualCAM machining job tree containing the 5 mop sets of toolpath operations. Here we see the completed results of the cut material simulations of the VisualCAM operation types used to machine the Dingwall D-ROC body. They include 3-axis roughing and finishing, as well as 2.5-axis pocketing, profiling, engraving, and drilling. Body rough and finish. The first mop set in the machining job contains toolpath strategies to rough and finish the top sculpted face of the D-ROC body. It starts off with a 2.5 axis engraving toolpath, followed with 3-axis roughing and finishing, and then 2.5 axis profiling. On the left, we see the 2.5 axis engraving toolpath is used to machine a bevel in 3 areas of the body, using a 38mm diameter by 45-degree V-mill. In engraving, the tip of the cutter follows the selected geometry, in this case 3D curves. On the right, we see that 3-axis horizontal roughing is used to remove excess material from the stock using a 25.4mm diameter flat end mill, a climb cut direction, a stock allowance of 1mm, and a step over of 50% of the tool diameter. In 3-axis machining, the visible 3D sculpted surface of the D-ROC body is used to calculate the toolpath in the Z-axis. A 2D perimeter curve contains the toolpaths in the X and the Y. Next up, on the left, we see a 3-axis parallel finishing operation. It is used to remove the remaining 1mm of stock using a 38mm diameter by 6mm corner radius mill. This operation uses a mixed cut direction and a step over of 1mm for an excellent surface finish. On the right, we see a 2.5 axis profiling operation used to cut the outer perimeter of the body. The 19mm diameter flat end mill follows a 2D planar perimeter curve with a climb cut direction. One cut level at 44mm deep cuts the perimeter in one pass. Pocket rough. The second mop set in the machining job is shown on the left. It contains 3 2.5 axis pocketing operations. They are used to rough out the neck, bridge, and pickup pockets using a 25.4mm diameter flat end mill. The offset cut pattern, climb cut direction, and 50% step over leaves 2mm of stock on the part. One cut level at a depth of 6mm is used with a ramp entry and a linear retract motion. Cut arc fitting is enabled for this operation with a fitting tolerance T of 0.1mm. On the right, we see the cut material simulation showing the toolpaths for all 3 operations. Pocket pre-finishing. The third mop set in the machining job, shown here on the left, contains 5 operations to pre-finish the neck, bridge, and pickup pockets, all using a 9.5mm flat end mill. The neck uses 2 2.5 axis engraving and profiling operations that follow the exact location and direction of the 2D geometry curves. Engraving is a versatile operation used when you want exact positioning control of the cutter at all times. The pickup pocket is pre-finished with a 2.5 axis profiling operation, and the bridge pocket uses a second pocketing operation, each leaving 0.5mm of stock on the vertical sidewalls of the part. On the right, we see the cut material simulation showing the toolpaths for all 5 operations. Pocket finishing. The fourth mop set in the machining job is shown here. It contains 3 2.5 axis profiling operations to finish the neck, bridge, and pickup pocket sidewalls. A 1/8 inch diameter flat end mill is used with a 10-degree ramp entry. These finishing passes cut to a depth of 3mm, leaving 0 stock allowance for the exact assembly fit required for the neck, bridge, and pickup components. On the right, we see the cut material simulation showing the toolpaths for all 3 operations. Final slots and holes. To wrap up the D-ROC body machining setup, the final mop set includes the mounting and accessories using 2.5 axis engraving, pocketing, and drilling operations. The first 2 are deep drilling for the bridge, 1.984mm diameters, using a 3mm step increment. The second is a standard drilling operation for the pickup, using a 4.76mm diameter drill. These are followed by an engraving operations for the truss rod slot and bridge ground slot, and finally a pocketing operation for the 3 9.5mm diameter control knob access holes. Here we see a close-up of the cut material simulation showing the toolpaths of all 5 operations. Now, sit back and enjoy the cut material simulation of the Dingwall D-ROC body in VisualCAD CAM. We hope you enjoyed learning about this cool project as much as we did writing it. We also want to extend a very special thanks to Sheldon Dingwall and his team at Dingwall Guitars for allowing us to share their phenomenal success story. We couldn't let you go before proudly showing off more picks from Dingwall Guitars. Dingwall Guitars has now manufactured over 20,000 electric bass guitars, each a work of art, craftsmanship, and companionship. Dingwall Guitars offers multiple lines of ready-to-play electric bass guitars, including the Combustion, NG Adam Naughty Getwood Signature, and the D-ROC models. Dingwall Guitars offers multiple lines of fully customizable electric bass guitars. You can select from the wood finish and neck inlay options. Here are just a few. Dingwall Guitars boasts some of the finest electric bass guitar players in the industry today. Here are just a few. Be sure to visit dingwallguitars.com for their complete line of ready-to-play and custom electric bass guitars. Dingwall basses have been synonymous with great tone, definition, and the best bee in the business. But don't take our word for it. Visit them online at dingwallguitars.com to see and hear what industry legends and everyday rockers have to say. Sheldon Dingwall is the winner of the 2018 SABEX Entrepreneur of the Year and 2017 Business of the Year. Congratulations to Sheldon and his great team at Dingwall Guitars. VisualCAD CAM is available in 5 configurations: Express, Standard, Expert, Professional, and Premium. The part shown here was programmed using the Professional configuration. Here are some additional details about each of the available configurations. For the complete features list, we invite you to visit the VisualCAD CAM product page. See the link in the description below to download your VisualCAD CAM today. This video was brought to you by MecSoft Corporation, your CAM partner.